guys, welcome back to another video. Today I will be talking about Mersenne prime numbers and perfect numbers. Well, basically Mersenne prime and perfect numbers and how we can relate those two things. Okay, so now, well, let's just get into the video and we can see. Well, before going into this video, I'm just going to assume that you know what prime numbers are, and in case you don't, I'll just do a small recap of it. So basically, prime numbers are basically the numbers which are not divided by any positive integer except 1 and the number itself. Basically, n does not divide p for all n belonging to z plus minus 1 or p. This is basically the definition of a prime number. A few examples of prime numbers are 2, 3, 5, 7, 11. Well, 6 is not a prime number because it is divided by 2 and 3. Okay, so now that we have gotten this clear, well, I did this a bit fast because most people know what prime numbers are. Well, let's look at Mersenne prime numbers. Okay, so the definition of Mersenne prime numbers is really simple. Mersenne prime numbers are basically all the prime numbers of the form 2 to the power n minus 1, where n is a natural number. And another interesting fact about this, and this is basically a prime number. And another interesting fact about this, let's say we have n is an even number. And let's just say k is greater than 1. Okay. Basically, n is an even number which is greater than 2. So now if we write 2 to the power n minus 1, we can write this as 2 to the power k square minus 1, which is basically 2 to the power k minus 1, 2 to the power k plus 1. And you can see that if k is equal to 1, this thing becomes 1 and this thing becomes 3. So 3 is a prime number. So let's look at k greater than 1. For k greater than 1, neither of these numbers are 1 or 2 to the power n minus 1. Right? So basically we have two numbers which divide 2 to the power 2k minus 1. So 2 to the power n minus 1 won't be a prime number if n is an even number greater than 2. So basically 2 to the power n minus 1 where n has to be odd, right? Basically all Mersenne prime numbers have n being odd except 3. So basically if you take 3 as an exception, all Mersenne prime numbers have n odd, but the converse need not be true. If n is odd, 2 to the power n minus 1 need not be prime. Let's take n equal to 9. 2 to the power n minus 1 is 511. Right, 2 to the power 9 minus 1 is 511, and you get that is 7 into 73. Right, so by definition this is not a prime number. Okay, so now what is the now you have a small grasp on what Mersenne prime numbers are. So now let's look at perfect numbers. Okay, so perfect numbers. Well, what is the definition of perfect number? Well, let's look at this number 6. Okay, so now what is amazing about this number? Well, it's definitely not a prime number. You can divide it by 2, you can divide it by 3. Well, you have 2 into 3, right? That is 6. Now let me just take out all the factors of 6. So well, you have 1, you have 2, you have 3, and obviously 6. These are basically all the numbers which can divide 6. So because 6 divided by 1 is 6, 6 divided by 2 is 3, 6 divided by 3 is 2, 6 divided by 6 is 1. Okay, now let's take all the proper factors. Proper factors is basically all the factors of a number excluding that number. And now if you sum up all the factors of this number, you get 1 plus 2 plus 3 and you get the number itself. This is the definition of a perfect number. This might not be true for all numbers. Let's just take 9. You get 1, 3 and 9. Cut 9 out. The sum of this is 4, which is not equal to 9. So perfect numbers are special numbers. Now, how am I relating this to Mersenne prime numbers? Well, what I'm trying to say this, that if you have a Mersenne prime number, if you have a Mersenne prime numbers of the form 2 to the power n minus 1, my claim is that 2 to the power n minus 1 into 2 to the power n minus 1 is a perfect number. Okay, this sounds nice. 2 to the power n minus 1 and 2 to the power n minus 1. Okay, so now how do you prove this? Because you need to find out all the factors of this, right? And well, there's a simple way to do this. You know 2 to the power n minus 1 is a prime number. Okay, so now I'm just going to take a small detour, and so let's look at how to find sum of all the factors, right? Okay, so now how do we look at this? Well, so this is one theorem in number theory where basically you can represent any number x as a product of all its prime factors. Well, basically if you take all the factors of x, and let's say in the factorization in all the factors of x, you find these prime numbers. Well, like in the factorization of 6 you found 2 prime numbers. Factorization of 9 you found 1. Let's say you have 12, you can write it as 1, 2, 3, 4, 6 and 12. Well, the prime factors of 12 are 2 and 3. Okay, so now basically these are all the prime numbers which divide x, right? So any number x can be written as an exponential product of these prime numbers, right? Okay, and the thing is, well, all the factors of x are of the form where Ln is less than or equal to Kn, which is greater than or equal to 0, right? And you can see why this makes sense, because if you take x divided by y, you get another p1 to the power k1 minus l1, which is, and this is a, well, this is greater than, this is an integer which is a non-negative integer, so this gives an integer, and you can do this for all k numbers. So well, x by y is an integer, so you can see that y divides x. Okay, so basically this is basically how you can represent any factor of x. So now I want to find a sum of all these factors. Well, so now I'm just going to write this down. You can write the sum of all factors of x as 1 plus p1 plus p1 square up until p1 to the power k1, right? And you can do this for all prime numbers, all the prime factorization of x. Now let me explain it to you how it works. So let's say for all the factors, let's say you well, let's say you want to find a factor, choose an L1, you can choose that prime number over here. Choose L2, you can choose that index of the second prime number, and so on, and you can basically get all the factors of x, and you basically sum it up, right? Okay, and so basically that's how you find the sum of all the factors of a number x, right? So now why is this useful? Well, you can basically, let's say we take this number 2 to the power n minus 1 into 2 to the power n minus 1. Well, we have 2, and this is basically, let's say this is x, and now we know that 2 is a prime number, and we have also been given that 2 to the power n minus 1 is also a prime number. So now we can write the sum of all the factors of x as 1 plus 2 plus 2 square plus up until 2 to the power n minus 1, right? And we can also multiply by the sum of all the p2 powers, which as it turns out is just 2 to the power n minus 1 to the power 1, right? And now by the sum of geometric series formula, we get 2 to the power n minus 1 plus 1 minus 1 divided by 2 minus 1, because that is the common ratio, and we get this as 2 to the power n, right? And now we can write this as 2 to the power n minus 1 into 2 to the power n. But look, if you look at this, when I say the sum of all factors, it includes the number itself, because you can take the k1, you can take the last prime number over here, and you'll find that in the sum of all factors you have p1 to the power k1 into p2 to the power k2. So, and if you want to find the sum of all the factors which are, if you basically want to find the sum of all proper factors, we will have to remove the number itself. So we will remove 2 to the power n minus 1 into 2 to the power n minus 1. So we have 2 to the power n minus 1 into 2 to the power n minus 1 into 2 minus 1, which is basically the number itself. So basically, if you have a Mersenne prime of the form 2 to the power n minus 1, 2 to the power n minus 1 into 2 to the power n minus 1 is a prime number, is a perfect number, sorry. Well, if you look at the first example, if you take n is equal to 2, you have 2 to the power n minus 1 is equal to 3, which is a prime number. And if you use this formula, you have 2 to the power 2 minus 1 into 3, you get 6, which is a perfect number, like I've already discussed. We can also look at other examples, like take n is equal to 3, then you get 4 into 7, which is 28. All its factors are 1, 2, 4, 7, 14. Yeah, there you go. This gives 11. 11 plus 3 plus 14 is 28. Okay, so yeah, that's all about Mersenne prime and perfect numbers. Well, I hope you enjoyed this video, and you know what, I'm gonna upload one video where I try to code this on Python. So well, you can find out a lot of Mersenne prime numbers and a lot of perfect numbers, and it'll be super fun. That was basically my entire 11th grade.